Hello and welcome. Our task for problem 1 is to design a control system for this simulated Turtlebot 3 robot in this gazebo environment. Okay, for that purpose, we were asked to design two nodes, one control node and the source node. Now, we start by looking at the code for the source node. We start by importing raw spy and the string class from the standard message package. Why we do that? Because in the string type is required to communicate between source node and control node via this topic source to control. Okay. Define get message, and we create an instance of recognizer class from the speech recognition module with microphone as source. Okay, that's pretty self-explanatory. Now we will try to listen to the microphone, and in case any exception happens, we will handle it accordingly. The exceptions are namely the unknown value error. For example, you say something, but it is not any of these commands. I mean the forward, two forwards and left and right and hill. So we have to handle that, and we also have to handle a timeout. For example, if the microphone is completely mute, it's completely silent, then we have to handle that too. This piece of code tries to adjust for the background noise, and here is just a prompt. Okay, here is a timeout. We'll listen for 3 seconds, and if the microphone is silent for 3 seconds, it will throw the wait timeout error, and it will just print timeout into the terminal. Anyway, so we are using Google's speech recognition capabilities. So it is important that there should be an internet connection. Internet connection required. Internet connection required. What is going on here? We listen for it. And if in the string, in the text here, in this text here, there is a forward 5 seconds. If someone says forward 5 seconds, there will be a part that says forward 5. We are trying to detect that. And if that is the case, we are encoding it. We are encoding the instruction in this variable message so that I can send it to the control node easily. Now, similarly for the rest of the commands, we do the same. We encode the message and later send it to the control node via the topic. In the main body of the function, we start by initializing the node and then initializing a publisher to the source to control topic with a queue size of 10. And we publish at a rate of 0.5 hertz, that is every 2 seconds. We print the message into the terminal also so that we can see it. In the control node, we import raw spy and also import twist from the geometry messages package. Why you do that? Because the control node will write into the topic of the Turtlebot in this format. Anyway, now we define a class turtle mover that will actually implement all the functionalities intended for the control node script. We initialize the command by an empty string. We initialize the publisher to the cmd val, and here are two publishers because I tested the code into the turtle sim node first and then actually moved on to the bigger Turtlebot simulation. Anyway, so we set a rate and we initialize the battery. Now this execute command function is actually at the heart of everything. We intend this function for public use, and all the other functions of this class that are just below the execute command function are intended for internal or private use. Private. Oh my bad. Private use. So the execute command function, as its name explains, it receives a command and then does something. What it does, if the command is F, it moves forward. If the command is forward for 5 seconds, it moves forward for 5 seconds. Now all these functions are implemented here. The forward function. We intend to move forward for 2 seconds, so we start a timer by using the time class, the time package from the ROSPy module. Now we check if the battery is greater than 0. If not, we don't move. We run the loop for 2 seconds. For 2 seconds, we input the time here. And yes, we set linear velocity to 1 and angular velocity to 0, publish that message, and after everything is done, we set the linear speed to 0 again, publish that message. We also reduce the battery. Each time, for each second it moves, we reduce the battery by 5%. Then similarly, the turn function. Now, how do I implement the turn function? And I actually messed it up somehow. I don't know still how I messed it up, but we again check for the battery. I implemented the turn function by setting a duration of the movement and moving it at an angular speed. I have set the duration to 1 seconds and set the angular speed to pi by 2 radians. So it should, in theory, move for 90 degrees. Similarly, publish the message, and at the end, we set the velocity to 0 again, the angular velocity. And here is a heal function too. When I say heal or kaboom, the battery heals. The battery gets filled up again. And in the main function, in the main section of the function, we call the function and implement all of this. Okay, that was the code, and I guess now we can see it. Launch this one. Launch that one too. Forward 5 seconds. Turn right. Turn right. Forward. Heal yourself. Forward. Forward 5 seconds. Okay, that was it. Now you can notice some problems that when I don't say anything, it shows heal, and that shouldn't be the case at all. And there is another problem that when I say forward in this, that bot doesn't actually, it does move forward. It move forward right now, but it also has some angular component to the motion. And why it does that, I have no idea. I have tried to fix it, but I couldn't. Anyway, that was it. Thank you and bye.